Welcome, everyone. We're going to get started in just another minute or two. I want to give folks just another few seconds to join. All right, let's go ahead and get started. Welcome, everybody, to our Mastering OpenTelemetry series. I'm Ryan Goins. I'm our head of product here at ObserveIQ. And today is our second session in the Mastering OTel series. So last week, we did OpenTelemetry 101. If you missed that, we've got an on-demand version of it we can certainly provide. Today, we're going to do a deep dive into the OpenTelemetry collector. And over the coming weeks, we'll go through kind of how to build your own collector, actually constructing pipelines, instrumenting your code base with OpenTelemetry, and managing really high volumes of telemetry with OTel. So lots to cover over the next month or so. We're really excited about this series. Hopefully you've been enjoying it. So with that, today we're going to talk about the collector. I'll hand it over to Mike to do so. If you have any questions, please feel free to just throw them in the chat throughout the webinar. We can certainly answer them as we go, or we'll make sure we have some time at the end as well.
And I also say if there's anything specific that you're hoping to see in this, feel free to throw it in the chat early on. And thanks, Ryan. I'm Mike Kelly. I'm CEO, founder of ObserveIQ, and excited to talk about the OpenTelemetry Collector today. Something that we've done a lot of work on as a company over the last few years. Been very involved in OpenTelemetry and specifically on the collector itself, including contributing quite a few of the metric and log receivers and the log engine component of the OpenTelemetry Collector. So very excited to get started. Few things that I plan to go through today. One, just a general overview, and if you've seen previous or were in the previous session, some of it may be repeat, but we'll go through it quickly. And then talk a little bit about configuration, deployment options, some of the core concepts around receivers and processors and exporters, and then some more advanced concepts and also best practices for deploying, configuring, and some newer things in the collector as well, in ways that you can take advantage of all the power that's built into the OpenTelemetry Collector. So before we talked about what OpenTelemetry is, and I said it's three core components: protocols, instrumentation, and the collector. And so today we're really just focusing on the collector. This is the vendor agnostic agent, supports traces, metrics, logs, and processing of the data, and lets you build pipelines to process, manage, and transmit telemetry that you're collecting. It's designed to receive and process and export. It's also been designed with usability, extensibility, a lot of flexibility is baked into the collector, and that can be, it makes it very powerful and also can be complex. And it can be tough to get started initially, but really the benefit of this is that you no longer need multiple agents, proprietary agents. You can use one solution for all of your telemetry. And this diagram gives you a sense of the different components that the collector can ingest from. So whether it's instrumentation from microservices through an OTel API or SDK, directly from infrastructure, client instrumentation, and then all the processing can happen within the collector before sending it along to your observability front ends. And when we think about the collector, really the three core base components are receivers, processors, and exporters. And there are more that we'll talk about, but the receivers, this is just components that are used to collect telemetry, whether it's metrics, traces, or logs. There are close to 100 receivers that are available that are part of OpenTelemetry, and then many more that are developed by third parties or vendors. It's a way to get the data in, get the telemetry in. Processors, they let you transform the data. And it can range everything from redacting data, filtering, doing things like sampling, also batching it to make it more efficient and compress the data as it's passing through, and more. But that's really anything that you need to do with your telemetry once it's within the collector is typically done by a processor. And then exporters are pretty straightforward. This is sending telemetry to the destination, whether that's something like a New Relic or Google Cloud or Kafka, Cassandra, OTLP, which is a standard OpenTelemetry protocol that's used to send and transmit data. But there are exporters for nearly 50, maybe 50 at this point, different destinations. And those are open source. They're also proprietary. The collector has been adopted by nearly everyone in the industry, at least supporting it, if not using it as the default for their telemetry. I talked a little about distributions last time we chatted, but there are three kind of groups of distributions. One is official distros. This is the contrib collector has almost everything, so it pulls together the majority of the processors, receivers, and exporters, and bundles them into a single distribution. That's probably the most used version of the collector that's out there. The other official core has minimal components. There are vendor distributions. One, the ObserveIQ BindPlane agent, which has some additional functionality baked in. There are also vendor distributions for Splunk, AWS, many others have their version of OpenTelemetry. And you can also build your own. And next time, we're going to get more into how and when you would want to build your own collector and what that looks like. Today, we're mostly going to be looking at the contrib collector. And this is going to be applicable to almost every distro. It really just depends on the components that are available. But for this, we're going to use something that has a lot of the components already baked in. And then for deployment, it's a well-supported package. It supports Windows, Linux, Mac. There are installation options out of the box that are available on Linux package managers. Also well supported for Kubernetes, including Helm charts that are maintained by the OpenTelemetry project. There's an OpenTelemetry operator that you can use in Kubernetes. And then when it comes to things like Ansible, Puppet, Chef, those are typically, you can find those available from a third party, or at least examples of how to deploy and use automation for deploying OpenTelemetry. But it gives you a sense. And OpenTelemetry Collector it's a Go-based application, and that makes it widely compatible. So these are the operating systems, the processors that are supported in the default builds. There are people using this on a lot of other kind of edge case or unusual platforms as well. And there's a good chance that it'll work on something not listed here or can be built for that. But in terms of what's available out of the box and in the distribution and built automatically, this is what you would typically see. Okay, so we're going to get into the three kind of key concepts. Before we do that, we'll talk a little bit about the configuration, and it all comes back to how you configure it. And within the configuration, it's structured well to understand how do we define those components, and then how do we use them. And link them together into a pipeline. So in any OpenTelemetry collector configuration, you're going to see a section for receivers where you define the receivers that you're going to be using. There's a section for processors where you're doing the same thing, defining the processors that you can use, and then exporters. So those three are key. There are also the option to define extensions and connectors, which we'll talk about a bit later. So you're defining those components first, and then you're putting them together into pipelines. And pipelines are really just saying, how do we connect those for either traces, metrics, or logs, or all of them? And you're not limited to a single for each. You can really have as many pipelines as you want. They are going to be broken down into different telemetry types like that. But you can pull these together and put together some pretty advanced processing capabilities and pipelines within this collector configuration. So the first thing we'll start with is receivers. And receivers are a fairly straightforward concept, but there's a lot within the scope of this. This can be used to collect metrics, traces, or logs. So there are receivers for metrics, including one I'm showing here for host metrics, gathers host metrics from nearly any system. There's a receiver here that's ingesting OTLP, so standard OpenTelemetry protocol, listing on a single endpoint for that. There's a metric receiver configured for Nginx. I also have one for generic HTTP, where it's listening on an endpoint and configured for TLS. One thing to note, TLS is available for nearly everything, nearly every receiver, and you can configure it just like this, adding in a TLS tag and then deploying the cert files. But there are over 90 of these. Look at this quickly, ranging from generic file receivers to things like very specific IIS receivers for Microsoft IIS, gathering metrics. It's a range and it's for all telemetry types. One of the best places to find something, so if we're looking for a certain receiver, if you have a specific application that you're looking to monitor, or you have a certain protocol that you need to ingest, you can find it here. And so if I'm looking for, say, Nginx, pull that up in the registry, we see there's an Nginx collector receiver. You can go to that and see what the configuration options are. And this is a simple one. There aren't a lot of configuration options for it and there aren't many that are necessary. But anything that you find, you can come pull it up directly, and then you'll have an example of a configuration and the options for using that. I'm also going to jump into BindPlane quickly to show you the sources. And these are the sources that we expose in BindPlane. These are receivers for logs or metrics or traces, but it gives you a sense of what's available, including things like parsing for CSV or just raw files, host metrics that I showed you, things like HTTP, generic HTTP, you can ingest that as well. So there's a lot available for receivers, and then those can be easily configured. And when you're building the configuration, you said you're defining what those receivers are. That's the first piece, and then later on, we're going to add them to a pipeline. The next concept is processors. So processors, there's a wide range of use cases for these. It can range from batching. Batching is something that allows you to compress telemetry as it's passing through, and then determines how many of these objects are you sending along to the exporter at a time. Can also allow you to transform data. So if you want to convert it from one format to another, you can do that with processors. You can mask and redact, and I have an example of that here where we're masking data using a regex and eliminating credit card numbers and email from that telemetry as it passes through. So there are a lot a lot of different use cases for processors, and this, when combined with the others, is one of the things that makes it really powerful and lets you build your telemetry pipelines. It also allows you to add metadata, and we'll see in a bit that you can pull things like metadata from different clouds. So if you're running on AWS or GCP, you can pull details about those systems and then include it in your telemetry as you're sending it through the pipeline. And I'll give one example to help you visualize some of the things that you can do with a processor. And this is a visual representation of a configuration where I have metrics and traces. I'm gathering them from a host metrics, gathering logs from, in this case, IAS and some Windows events. And this is the processor component. So it's the things that I'm defining in the configuration are represented here visually. But these are a few processors that we're adding. So if I have log data coming in on this side, I see the output over here. I can look at things like I have a processor to mask sensitive data. That's doing is it's looking at the IP address in this case. And on the other end, it's masking that and obfuscating the IP. But we can also do things like with metrics, we can gather metric statistics, we can deduplicate logs, you can remove empty values, parsing different data types, like parsing out JSON and converting that to OTLP objects, and then also adding, removing, moving fields. And then some of the standard components like batching, grouping by attributes. These are all available as processors. Some of these are available in the BindPlane agent, but those can be pulled into a custom build if you are looking for some of these specific processors. So a couple of them I wanted to call out when we're talking about processors. The batch, I mentioned this a couple of times. This is something that is typically recommended. Once you reach production, you want to use the batch processor to better compress your data and reduce the number of outgoing connections. And so this is usually applied at the end of all of your processing. You'll do the processing, then you'll batch it, and then you'll send it along to the destination. One that is not necessary in most cases, but can be very useful is a memory limiter processor. And this is one that is provided so that you can verify, especially on a mission critical system, that if you do think that there's a chance that you could exceed memory limits, you can put this in place to validate that it never goes above a certain level. And last, I mentioned the resource detection processor. This is something I know a lot of our customers use. It's a processor that will detect from a range of different environments. I'll actually click into this one. So in this, it gathers general system metadata, so the architecture, the name, ID, things like the CPU, and you can select which of these you want it to detect. But it can also be configured to detect different environments. So you can turn on a Docker detector. You can turn on AWS or GCP detection, and then it'll include additional metadata within your environment. And you can be selective about this, but what this lets you do is if you have a collector in a certain cloud and you want to pull certain details about that, maybe you want the account ID for all of the collectors within a certain cloud. And then you can filter that data and do things like chargeback on that data with those IDs. And so those are a few of the ones I wanted to call out. I mentioned a couple others for processing and filtering. Next time when we're building out the pipeline, we'll talk a little bit more about how all of those come together to reduce and route data. But these are the key building blocks that you need when you're putting together configuration, putting together a pipeline. And the last piece of this, of the core three components, is the exporters. It's probably clear by now what these are doing, but a few examples here. One, we have an OTLP exporter, just configured for a specific to target a specific endpoint. There's also an AWS S3 exporter, and then I have a Splunk exporter here as well. And you can have multiple exporters, really have as many as you want within a single configuration, a single collector. You're just going to then configure them in the pipelines. But there's around 50 of these that are available. Pretty much any destination you can imagine, if it's a observability backend, open source solution that would be ingesting telemetry, there's probably an exporter for it or a way to get data from the collector to that backend. One other thing I'll call out as we're going through this is a different concept I didn't show in the previous examples of the configuration. In this case, we have OTLP. So when you define an exporter, use the name of the exporter. In this case, the name of the exporter is OTLP. It's AWS S3. And then the slash allows you to give it a unique name. So if you only have one of them, it's fine to just define it as OTLP. In more complex configurations, it's usually going to make sense to give it a friendly name. I'm calling it OTLP demo exporter in this case, S3 archive app. And then you'll always refer to it by that full name going forward. So once you have those components defined, that's when you can put them together into pipelines. And pipelines are easy to create. So in the case where I have a receiver for OTLP, I would create pipelines for each, whichever I want. If I want a trace pipeline, I'd add a receiver for trace, so OTLP, a processor that's batching, and then an exporter to a different OTLP destination. So this is about the simplest pipeline that you can create. But I've done that for traces, metrics, and logs. And just like I was mentioning before, with pipelines, you can have, if you only have one trace pipeline, it'll look just like this. If you want to have multiple trace pipelines, you will give it the same type of friendly name, traces slash trace one, traces slash a specific pipeline name. And you can define multiples that way. But this is a way to, combine all the receivers, processors, and exporters, and also connectors, which we'll talk about in a minute, and put those into pipelines and keep that neatly defined. And it's really where a lot of the power of OpenTelemetry and the complexity of OpenTelemetry comes in. A couple of other concepts here. One is extensions. And so if we think about what we defined here, the pipeline is really defining your receivers, your processors, and your exporters. And so it's everything within that pipeline or within the processing workflow. Extensions are components that exist outside of it. So they're typically optional components. They expand the capabilities of the collector, but not necessarily what's happening processing the telemetry. So it's usually something that doesn't ever touch the telemetry as it's moving through the collector. But some examples of those, and there are maybe a couple dozen extensions right now that would be considered official or a part of the OpenTelemetry project. But some of the key extensions, authentication is one that's used frequently. And there's an OAuth 2 authentication extension, basic auth extension. Those are defined as extensions, and then they can be used in receivers or they can be used in exporters. Another one that's really key is the storage extension. And this is important for doing things like data queuing. So you can define a storage extension. You provide some file path information, or you can use the database backend, and then you have a local queue for your telemetry. We also have an extension for OpAMP, and this is a newer remote management capability of the collector. It's defined the OpenTelemetry management protocol. It's defined as an extension and can be included to provide remote management capabilities of a collector. And this is also the way a lot of the debug functionality is defined inside of the collector. So profiling, Z pages, health checks, those are all extensions that you can enable or disable, include or not, and then you'll have that functionality available. One thing I'll mention with extensions, it's important to remember, despite the fact that they exist outside of your pipelines, just like everything else, like your receivers and your processors, they don't do anything unless they're actually included in this service section. So unless you have, say, a receiver that's defined in a pipeline, it's not going to do anything. It's really not part of that pipeline. With extensions, they need to be defined and then listed to enable them when the service starts. So I mentioned with the storage extension that it provides you with a file store backing the collector, a local file store. And this is really important for building storage queues. So if you're running the collector and you, let's say you have a SLA or requirements that you really can't handle data loss from network interruptions, and these are common, right? If you have a network interruption between collectors or sending data from your collector to a destination, without any type of file storage, you're eventually going to run out of storage queue. And so what's available within the collector and within extensions is the ability to define a file store, a local file store. That's what we're doing here, using the file storage extension. We gave it a name, so it's referencing back to this exporter. But this file storage extension just defines a location, some additional requirements in terms of how it's used. Is it going to rotate those files? But you define that file store, and then it can be used within an exporter. So what we're doing here is defining a file store, and then we are enabling that within a sending queue. So if we lose connectivity to, in this case, the Splunk backend, we're not going to lose that data. It'll continue to queue the data in a file up to a certain point, and then when the connection is reestablished, it will resend that data. So this is an important concept for some customers if you have strict requirements on validating that data is able to get to the destination. And when you're doing this, you do need to be careful of your queue size. That's something that's going to be sized according to the system that's running on. And so there's a limit, right? If there's no limit, or if you let this expand, it could impact the services that you're running on that server. One of the newer concepts within the collector, this is the most recent component to be added to the collector, is connectors. And this filled a bit of a gap in the collector and the collector architecture. This is both an exporter and a receiver, and it can connect to pipelines. So it's consuming the data as an exporter. So you would define it within a pipeline. Instead of defining an exporter, you define a connector. But it's not going to send to a destination. It's going to send to the beginning, or to a connector at the beginning of another pipeline. And this is important as you're building out more complex pipelines. I give a really simple example here where we have two receivers, one we labeled traces, one labeled metrics, one exporter named bar, and then a connector, in this case, a count connector. So we define that traces pipeline. We have a traces receiver, and it's sending to that count exporter or connector. Now, if it's sending to count, then it's going to also, in this case, it's defined as receiver. So what we've done is we have two pipelines, trace and metric pipelines. and it's collecting data into the trace pipeline and then exporting it into the metric pipeline. This is something that becomes really useful if you're converting from one telemetry type to another, or it can also be useful if you're just forking pipelines, sending to through multiple pipelines for two different types of processing, but it allows for a lot of flexibility. There aren't a lot of connectors right now, and there probably won't be too many connectors. It really is just that linking component. One that's good to know about is the forwarding connector, and this is just going to merge. It's really not doing a lot of processing on that, but it can merge or fork multiple pipelines. Another is routing. Routing is an important one because it allows you to connect data, but then it will only transmit data or telemetry matching an OTTL statement. And OTTL is an OpenTelemetry query language that allows you to do things like processing on that telemetry data. And the one that I showed is a somewhat trivial example of a count. It's still really useful in that you can have a connector that's counting log lines and then sends it as a metric into a metric pipeline. That's something that a lot of folks will do just as one method of reducing the total amount of telemetry data within their system, converting from logs to metrics, or consolidating, deduplicating. Things like that are some strategies you can take to reduce the amount of data, ultimately reduce the cost of managing your observability backends. A couple of thoughts on local testing and debugging. So one of the challenges that you have, this can get fairly complex, and it can be hard to debug if you're trying to send everything to, say you're sending it to Splunk or to Google Cloud, and if the whole pipeline is defined, it'd be difficult to figure out where that issue is. And so OpenTelemetry comes with a couple of things that are dedicated to debugging, and then some things that we've found we use internally, and a lot of folks will use as they're working through issues. Now, the first step, if there's an issue with the collector or starting up, is to look at the collector log file. And that usually is a great place to start. We'll let you know if there's any major misconfigurations or issues with your setup. But once you have a working pipeline or working configuration, and you're starting to make changes and validate that those configuration changes are doing what you want it to do, there are a couple of things that you can use to debug locally. One is actually a special exporter called the debug exporter. It does what you would expect. You can enable this as an exporter. You then put it within a pipeline, and then that will output a lot of the detail on telemetry and what processing was occurring as it was passing through the collector. And we can look at some of the details of this. This is actually part of the OpenTelemetry core. So this is considered a core component of OpenTelemetry. You can control the verbosity, the sampling intervals. This gives you a sense of the type of output and things that you would see as if you enable debugging or enable the debug exporter in OpenTelemetry. Even sometimes this is a simpler method of that, and it's maybe more representative of what you're doing if you're sending to a backend, is just to use a file exporter. So it's the same thing as we've created or set up our receivers, we've set the processing, and now instead of exporting to something that isn't local, we can just write that to a file. So in this case, I just defined what I have as the OTLP exporter. This is what I'm using in prod, sending to an OTLP destination, and then two exporters that I can use for debug. And if I wanted to enable this, it's really just changing the exporter from OTLP to, in this case, debug. So if I saved that and then reran, I would then have it outputting to a file locally. So that's a useful way to validate and test out what you're doing. There are a number of other ways. One, Z pages. This is an extension. If you enable this extension, you'll then have access to a lot more and granular debug data about what's happening within the collector. And I mentioned earlier some profiling extensions as well. If you turn on the pprof extension, it will allow you to generate full profiling data for the collector. So if you're getting into things like collector development and you want to validate a change and understand what the performance impact of that is, you can just turn on this extension and then you have access to profiling of the Go binary. I want to talk a little bit about the collector as a gateway and to just define some terms here. If you look at the OpenTelemetry documentation, you'll see references to agents and gateways. And that can be confusing, right? The OpenTelemetry Collector is the term that's used. If you see things talking about it as an agent, that is usually just talking about how you're deploying it or what the configuration is. So an agent is usually referring to a lot of basically the configurations that I've been showing you. It's a collector, maybe it's running on a host or in Kubernetes, but it's collecting telemetry directly from local application, from logs that are local. It's maybe ingesting data from another source, but then it's sending it, processing it and sending it to the backend. When you hear reference to a gateway or a gateway collector, that's really talking about an architecture. So in this case, I have an architecture where I'm gathering telemetry from OpenTelemetry collectors in an agent mode. They're then transmitting that to a OpenTelemetry collector in gateway mode, where it might do some additional processing, or it may be set up to like this just for scalability, or maybe you're trying to reduce the number of outgoing connections in a very secure environment. There are a lot of reasons that you might want this architecture. Sometimes it's just offloading the processing to a different system, but we would consider this a gateway. Now it's the same OpenTelemetry binary. There really is no difference. It's just talking about how it's used in an architecture sense. And it's very simple. So if we think about what the gateway configuration would look like, everything being sent, if it's transmitted from a collector to another collector, we use OpenTelemetry protocol. So OTLP for transmitting and receiving. And then we're keeping that data. We're not translating it from one format to another. This is the standard format for OpenTelemetry and sending OpenTelemetry data. So to create a gateway configuration, all we need is to set up a receiver that is receiving on a port OTLP, an OTLP receiver set up on a specific endpoint. In this case, I have it in the gRPC protocol. We then have any of the processors that we'd like or to apply to this data. And then we can export it to that final destination. So with this configuration, I have a really basic gateway config where I'm ingesting from OTLP, processing with a set of processors, and then exporting. You can also set up a gateway with multiple OTLP receivers, and that can make it a little bit easier to create multiple pipelines for multiple types of data. So let's say you have telemetry coming in from a certain application group, and you want to keep it entirely separate without doing any filtering, then you might create a receiver on a specific port, and that's where all of those collectors would send data to. And then for another application group, you create another receiver with another on another port, and then keep all of your application or telemetry data separated that way. You can do the same thing through filtering. It's just a little bit more, it's a little bit heavier, a little bit more work to do it that way. And then all the processing that you would want to do can be separated out and built into the pipelines, just like we were showing earlier. And this is some newer functionality in the collector as well. The Open Agent Management Protocol, this is a network protocol for managing fleets of collectors. It's been developed and it's starting with OpenTelemetry, but really the protocol has been defined to work with any agent type. So it's not tied directly to OpenTelemetry, but you'll see it. I think it's going to be seen first with OpenTelemetry collectors, just because it's coming out of that project. And this is added as an extension to the collector, and it's configured just like you would any other extension within the collector. Not widely supported by vendors yet. We use it heavily in BindPlane, and there are a number of other vendors, a couple that have come out with it with GA products that use that and implement an OpAMP server. And I think a couple others that are going to be launching that soon. But this is a really, I think, an exciting protocol for managing your agents at scale. This is something that was designed from the very beginning, with the intent that it could manage tens of thousands, hundreds of thousands, or really even, a million collectors, all from a single centralized OpAMP server. And because, the complexity of this can get pretty high when we're dealing with a lot of agents, and also the pipeline complexity starts to increase. Having that ability and visibility to be able to go in and make changes on the fly is really powerful and can be, I think, critical at a certain scale. And I can show an example of this in action to give you a sense of what that looks like. So we use OpAMP within BindPlane, and that allows us to generate views like this. So this is a OpenTelemetry configuration. We're connected directly to multiple agents. So in this case, 2 agents. We're managing those agents. And so if we make a change to a file, if I was to add some additional processing, we're able to get sample data from those collectors. I can then save this or validate that the changes I made make sense. And then we're able to deploy that, push that configuration out to multiple agents. And we can manage those at scale, but it allows you to do things like change where your data is flowing to. In this case, it's sending to Splunk in AWS, but I could really easily change that and send some of it to Datadog if I wanted to. Or I could remove the AWS destination, and now I'm just sending it to a single instance. But having that control and being able to do that in real time is really what OpAMP is designed for. And the next week we're going to get much deeper into this, but I'd say like the next level in difficulty in terms of OpenTelemetry is creating your own build. And there are pretty easy ways to do this. I like to tell people to start with the collector contrib because it has just about everything within it. You can decide what you need and what you don't. But we know that this is a well-validated version, a well-validated build of the collector. And so if you start with that, you can start to remove items. If you decide that you want to build your own distro of OpenTelemetry, this is how we recommend going about it. One is that you use the OpenTelemetry Collector Builder. So this is a project, it's a small application that was designed specifically to handle OpenTelemetry Collector builds. It's used for the core build, it's used for the contrib build as well. And it takes a manifest file. So it takes a file that defines all of the different components that are included in the collector, and then it will bundle them all together. And you start with that manifest, and then you take away any of the components that you don't need. Once you do that, once you have a build, you can add any additional, if you have custom components that you're building, if you have your own receivers that you're creating, if you want to pull in components from a third party or non-OpenTelemetry standard components, you can do it that way. But look at an example of the manifest. And this is an example of the collector contrib manifest. And there's a lot in this, right? Because there's a lot of the extensions uh, automatically included, most of the exporters, most of the processors and receivers. And so when you're looking to build your own, you're really thinking you want to start from this, take away all the components that you know you're not going to need. And the reason you might want to do that is it does end up with a somewhat smaller binary that's deployed, likely a somewhat smaller footprint depending on what you have enabled. But like I said, starting with the OTel collector contrib and then removing is usually the best way to approach this. And those are the main things I want to talk through. I will mention, for us, we have with OpAMP, we're really using BindPlane to leverage that to manage these across a wide range of environments and at scale. And BindPlane, with that capability, does let you take OpenTelemetry, simplify some of the things that you're looking at here, simplify the configuration, but still maintain a lot of that capabilities that you have by moving to OpenTelemetry. So I'm going to pause there and see if there are any questions on what we've gone through so far.
Yeah, thanks, Mike. Looks like we do have a couple questions. First is, looks like they just missed the first webinar last week, OTel 101. I want to know how to get access to that. We'll include a link to that first session in the email we send out following this one. So look out for that. And then second question, I'm going to do my best to try and summarize this. So this was submitted anonymously. If I missummarize, please let me know in the chat. But it looks like they want to use the collector on a segmented network that doesn't have access to the internet and are trying to get an understanding of what the architecture would look like there and how you might set that up.
Yeah. So I think so the collector can operate without any access to internet. And some of the challenges that you run into, well, frankly, it's going to be very similar to what you see in all the structure and definition that you saw here. There's no requirement. The only time you might have a requirement is if you're trying to use remote management from something external. But the remote management can also be handled internally in the network. I'd say there are options for proxying if that becomes something that's required within your environment. And that I would say is pretty common. We do have, if you have like a DMZ type of environment, that's when the structure I was showing before, where you have a gateway, is probably incredibly useful. Because if you need to get data outside, then you're really only exposing a single node, a single collector, and allowing that access outside of the DMZ. But there are a lot of good strategies for doing that, and there are a lot of customers that are solving that. So I don't know if that answers your question, but happy to answer any follow-ups if that didn't.
All right. Another question, monitoring is incomplete without taking actions like restarting or running a script or commands. We use the BindPlane agents and this option does not seem to be available.
Yeah, that's a good, well, maybe not question, but I know where you're going with it. It's a controversial take, and I'll tell you why. I think a lot of people have gotten used to the ability to run arbitrary scripts from a collector or an agent. And it is really powerful, right? The ability to execute and to take action in that way, in like an arbitrary way, um, allows for a lot of flexibility and a lot of power. I think as a community within OpenTelemetry, there's a decision to really limit that, despite knowing that it can allow for a lot of functionality because of the security concerns of allowing for something arbitrary. So what we do instead is try to build out any capabilities like that into their own receivers or exporters or extensions. So if there's an action to be taken, it means that there's more work, there's more has to go into validating and verifying and developing these components. But what you end up with is a much more secure overall solution. But you don't have quite the flexibility that you did with some solutions that would allow you to execute a script. So just create a script and run it on a server. But it is one of those things that we're looking at specific use cases. So I'd love to hear if there's specific ones. Feel free to shoot them our way and say, hey, this is what we're trying to do. How can we do that without, say, like allowing for script execution or arbitrary executable execution? Because it is it's powerful to be able to take that kind of action and to be able to build your own internally.
All right. Any final questions? All right. Very good. I'll say too, if anyone has any follow-up questions or wants to chat further with us outside of these sessions, of course, send us an email anytime. But if you go to our website, observeiq.com, in the footer, you'll find a link to our Slack community. Feel free to join that, and we're always hanging around there and happy to chat. So thanks for joining the session today. Like I said, we'll send out an email with a video recording of this and the previous session. And next week, we'll be getting into building your own custom collector.
And that's a lot of fun. So I hope you get to join that one too. Thanks, everyone.
Have a good day, everyone.